Hi everybody, welcome to the Manifold channel. Today we're going to learn how to use the expression template in the transform pane to take advantage of very powerful SQL functions. There's a lot of SQL functions in Manifold, hundreds of them, and some of them have tremendous power, and it turns out we can use those functions without knowing hardly anything about SQL at all by just popping them into the expression pane. And for an example, we're going to use the new TileMaskRange function, which transforms pixels and images into missing pixels, marks them as missing pixels based on their pixel values. And what we're going to work with here is this example of a Landsat image. I'm going to turn that off and on. And this is something that we imported from a USGS GeoTIFF, and it shows a Landsat image from the Landsat 7 thematic mapper, band 0, and the TileMaskRange function works with single channel images, and when USGS publishes Landsat imagery as GeoTIFFs, they publish them typically as single channel images using UN8, that is unsigned integer, 8-bit integer values. And what we're looking at here is an image, and I have it in a map with a Bing Street Maps background. And as you can see, this part of the image that's on the inside is composed of pixel values from 1 to 255, and that's a grayscale. And these blank pixels here have a pixel value of 0. And we want to get rid of the blank pixels so that, for example, when we turn on a satellite image background, we can see whether or not this image correctly lays on that map or not. And so I'm going to use this image, and to do that I'll use the transform pane, click on transform, and I'll choose the LT image right here. That's the Landsat name of the image. And I'm going to choose the tile. We're going to work with the tile value, that is the pixel values. And I'm going to double click on the expression pane. And here I'm going to edit the expression. And I'm going to use a single function, which is called tile. And to find it, it's TileMask. And I can't remember totally, but I'll just start typing the name of the function, and that'll reduce the list of hundreds of functions to these. And this is the one I want to use, TileMaskRange. Double click on that to enter that into the query builder. And then I'll delete that filter. So now I have all my other functions and fields and all the rest of it, because I want to pick fields. These are the fields that are in that image. And so let's start here. I'll go from left to right. I'll scroll to the left. And this works on whatever the tile field. In this case, the tile field is called tile. And I want to pick pixels from the range of 1 to 255, 255. And I want that range inclusive. That is, actually want to include the numbers 1 and 255. That is not from 2 to 254, but from 1 to 255. So for the inclusive flag, I'll make that true. Now, how do I know how to use these flags, what these mean in the functions? Well, I looked that up in the SQL functions, the tile functions part of the user manual, where there's a useful description of the TileMaskRange function. There's also a nice user example. And I want to make up I can decide whether to keep all the pixels unchanged that are within this range and knock out all the rest as missing pixels, or the other way around, that is knock out the ones within this range and keep the rest of them. But I want to keep the pixels unchanged within the range 1 to 255, so I'll make the keep range parameter true. Great, it's that easy to use, and we've just written our first expression here using a sophisticated SQL function. And if I want to see what this is actually going to do, which parts of it are going to keep, I can click the preview button, and you can see this is what it's going to keep. It's not going to keep the black pixels, it'll just keep these here. And what I can do if I want, I can update this image in place. But since I'm going to use this image in other examples, instead I'll send the result to a new table, that is a new image, and I'll call the new image masked. And down here I'll call this masked, the table for that image, masked tiles. Great. So when I click transform, it's automatically going to compute the result, and it's going to put it into that new image, create that new image for me. Click transform, and there it's done. It also automatically switches the project pane with the focus on this masked image that we just created. So let's turn off that Landsat image, and let's drag and drop this. Oops, I double clicked on it. Let's drag and drop the masked image into the map to see what it does. So you can see what we created. We instead of this one here, which had this black pixels, we knocked out those black pixels. We marked them as missing pixels. So now we can right click and drag to zoom in, and you can see how the all this stuff matches up perfectly. It knocked out the black pixels and made those made the missing pixels, so they're not rendered. And you can see how well the Landsat image lines up with the imagery that Bing is using. In fact, Bing may be using Landsat imagery for this scene. We don't know. So that was easy to do. And if we want, we can actually use a wider range. And let's use a wider range. So let's go back here to this image, and let's go back to the transform pane. The transform pane remembers what it did. We can modify this. We can modify the expression. Click Edit Expression, and let's modify everything from 1 to 100. All right. So we're now going to keep unmodified the range from 1 to 100, and we're going to make missing pixels of everything else. So outside that range, so it's going to knock out the black pixels because those are 0, and everything from 101 on up, which is the brighter regions, that's going to get marked as missing pixels as well. And let's call that mask 2. You can see how the workflow here using a transform plane is very efficient. If you don't want to change anything, no need to change anything because it still stays cool. And if I like, I can make the channel type. The prior one I didn't change the channel type, but I can make the channel type UN8 just like in the original Landsat image was as well. Great. So let's click Preview and see how that'll work. So okay, so that'll make so those are the images that it'll leave unchanged, and all the rest is going to knock out. If I wanted to, what's kind of cool about this, I could change that at expression. I could make that 150. Click OK, and now let's click Preview again, and you can see it'll be more. Now let's leave that at 100 because I want to make it a big enough change so that's a dramatic effect. Click OK, click Preview. So those are the ones that it's going to keep, and all the rest is going to knock out. And let's click Transform. Puts the result into Mask 2. Let's see what Mask 2 looks like. Let's drag and drop that into the map. And there. That's the Mask 2 image, where you can see it's got some of them, but not all of them. Turn off the Bing satellite image so you can see better on the street map image which pictures it kept and which pixels it knocked out. If we want to see what the inverse of all these things are like, let's again, starting with this image, let's go back to the transform pane and let's edit the expression so that so this last parameter is false. That's the ones that tells you whether to keep the pixels that are in the range or not. And what this will do is that'll invert the ones that are kept and the ones that are nuked. And so let's click Preview, and you can see the ones that it's going to keep and the ones that it'll get rid of. Let's call that Mask 3. And let's click Transform. Let's turn that off, and let's drag and drop Mask 3 as a layer into the same map. There. So what it did is it inverted that. So a bunch of the pixels that nuked as unwanted pixels, as missing pixels, and a bunch of the other pixels that kept. And if we like, instead of using this Bing street map, let's change the layer pane so that the background here is a nice bright color. Let's make it hot pink, so that shows you better which pixels were turned into missing pixels and which pixels were not. That's a quick tutorial on how to use this for regular imagery. I have another map up my sleeve here, though, which using entirely different kind of a. Let's turn that back on. I have another map up my sleeve here called the 1475 map, and this is a map that uses some layers that were part of a user manual topic that shows how to do contouring with rasters. And what we did is we started with this raster right here, which is colored using a thematic format. So pixels from 100 to 200 have this color, and 200 to 300 have the blue color, and so forth. And you get that nice display. And what's nice about Manifold is that you can create multiple different images, as many of them you want, from the same data. So for example, this single table called 1475 has got data for all those pixels in that region. And there's two rasters that have been created from that. One of them is this raster color contours thing, and if we like, we can right click on the property so we can see that it's taking its data from the 1475 table. And this other raster here is also created from that same table, but it's formatted completely differently. This is the elevation raster, and if you like, look at the properties, see it's taking its data from that same 1475 table. The difference is that this elevation raster table is formatted using this style, where it uses these color breaks, and everything from 250 to 300 is this bright magenta. It's also shown with partial transparency, by the way. Everything else is shown using transparent color. And this one right here, this raster right here, uses a different color ramp. They're the same table. These extra images take absolutely no extra storage space whatsoever, because all the data is in this table, and these images are just basically styles that show how to visualize that table. But that's what it is. Now, what we can do if we like, we can use the same technique that we used using the TileMaskRange to knock out as missing pixels things we don't want and create a series of new images with new tables which use portions of this image. And let's do that using the transform pane, using the elevation, and what we use the raster colors image, and I'll use the expression builder once again, and here we tile mask range. Let's double click on that, and let's go back here to the fields so I can point and click fields without having to keyboard them. Double click tile, and we'll use, in this case, the tile field is called elevation. The minimum boundary, let's make it a height of 250, and the maximum boundary, let's make it a height of 350. All right, we'll make that inclusive. True. And we just want to keep the pixels that are in that range. So let's make that true as well. All right, click OK. And so that's the expression that we want to use. And let's preview that. Let's see what that's going to do. Whoa, that's pretty wild. You can see what it's going to do. It's going to keep pixels in the range from 250 to 350. It's a pretty cool effect, don't you think? And let's put the result into a new field. So I don't want to change my nifty table that I created. Let's call it new image 250 to 350. And let's make the table similarly named tiles. Click transform. Great. Let's see what we created with this use of TileMaskRange. Drag and drop that into the map, and what do we have? We have that raster there. So far it's unformatted because it's unstyled. It's just an image. And what I can do is I can copy the styling from here. So use exactly the same colors. Copy that style value, and let's put that into this properties for here. Styles and manifold are just the style, in this case style pixel property. So we can copy, and they're just JSON expressions. So we can copy and paste them from one image into another and identically match the styling that we used. So you can see what we did here. What we did is we took, from this image right here, the pixels from the 250 to 350 range, and we knocked out everything else, all the other pixels, made them mark them as missing pixels, so they're not shown. And so that shows you the that kind of pseudo contouring effect that you get with by simply manipulating how pixels in the raster are styled and which ones are defined as mixing pixels and which ones are visible pixels. And that's shown against the Bing Street Maps satellite image background. This is all the Livermore Valley right here. This is Livermore, California. Here's the Lawrence Livermore National Laboratory. And up here is the Altamont Pass with a lot of windmills and so forth and so on. So I hope you've enjoyed this quick little view to quick little video to see how easy it is to use functions within within the transform pane. These are trivial expressions. It's just one function, and the function does what it does. If we wanted to, we could write arbitrarily complex expressions here, SQL expressions, using all the different operators, using all the full panoply of SQL functions that are available in SQL facilities with Manifold. Manifold has real SQL. It's not this fake SQL like you get with Esri or partial SQL with other packages that depend on databases. So you can do an awful lot. But as you see here, you can use the tremendous power of all those hundreds of different SQL expressions, just one function at a time if you want, and not have to mess around with learning full SQL just to get the power of a lot of these hundreds of functions. I hope you've enjoyed this quick video. Thanks for watching. Tell your friends. Try all this out in the free viewer. We've been working with Manifold System Release 9. All this works in the free viewer, which you can download and try for free, and have fun. So once again, thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.